Hey everybody, so I'm going to come back. We're going to talk about how can you find an excluded value. And so, basically what happens in an excluded value, whenever you have a fraction, you can have any number you want on the top. But on the bottom, there's always one thing that totally makes everything not work. And that is if you have 0 on the bottom. That is just a very sad day. You cannot have 0 on the bottom. So whenever the value of your variable would make the bottom be 0, then that's not going to work for us. It kind of blows up the whole thing. And I'll show you in a graph why that happens. So let's say, for example, that I have something like, we did a while ago, 4x minus 4. And then I divide that by 4x plus 4. Do you see kind of right here in the middle, there's like this random, right at -1, there's this place, like there's this invisible force field. It's called, I totally just blanked on what it's called. It's called an asymptote, which is just, again, like this invisible force field where the graph cannot cross. So if I do it down, you'll just see that it goes from the left and then kind of goes up forever. And then there's, again, this asymptote, and then it just hops over, the graph hops over to the other side. So that happens, whenever I put something. So let's, we'll make this bigger, maybe. Nope. And let's change this, the bottom, to x plus 4. Well, now, where does it go? You have this place right here. Where is the asymptote on this one? Well, the way you find it is you look at the bottom of that fraction. It says x plus 4. So the asymptote on this one is actually at x equals -4. What if I changed this number to a minus? Now the asymptote moves over to +4 because 4 minus 4 gives you 0. And this works. Now what if I did x squared? Let's see, what multiplies to give me -4? Let's say +1 and -4, so that's -3x minus 4. Now this one is going to have two different asymptotes. It's going to have one at -1 and one at +4. How come? Because that right there is the same as 4x minus 4 all over x minus 4 x plus 1. Look at same graph because you can factor that bottom down. So now you have an asymptote when x is +4 because 4 minus 4 equals 0, or at -1 because if x is -1, -1 plus 1 makes you have an asymptote, and that just is not going to work for us. All right? So I'm going to close this down. Let's go back in then and look at some of our examples. So in a previous video and on your notes, we have done these questions right here. And so when I simplified this down, what you do is you start simplifying and you look right in this place right here. Now the top, can the top be 0? Yes, because 0 divided by any number is just 0. But the bottom is where we have problems. So let's look. 3, there's no variable right there, but here's my variable, y. And so I have y plus 10. So if I have y plus 10, what makes that equal to 0? And whatever that is, that's going to be a problem. So minus 10, minus 10. So y cannot be -10. That's my excluded value, because if y was -10, the bottom would be 0, and then you would have an asymptote in there, or maybe a hole in this case. All right, let's look. Number 17. Do you see? Now here's my final answer. However, I don't look in my final answer. I look in my work. So I actually look right here. There's going to be two excluded values in there. The first one, what makes x plus 4 equal to 0? So x plus 4 equals 0. You might see right away, oh, x can't be negative 4, because if I solved that down, there it is. I get x can't be negative 4. Then what can x not be right there? Well, what would make x plus 2 equal to 0? That would be negative 2. So x can't be negative 4, and it can't be negative 2. How about 18? Well, even though my final answer right here only had the x minus 2 on the bottom, that's not where I look. I'm going to look right here at the bottom right there. So there are two excluded values here. What are they? Well, for this one, a plus 4 equals 0. What does a have to be? Well, if I wrote it out, a plus 4 equals 0, hopefully you'd see you have to subtract 4 from both sides. So a cannot be negative 4. Now, can you figure out what it is right there? A can't be 2. All right. Look at these guys right here. So I've already done the work for you. This is in the video of I can simplify rational expressions. I would like you to look right here and tell me what the excluded values are. Look right here and see what the excluded values are. And let's see, look right here, or really right here, and tell me what your excluded values are. I'm going to pause the video, and then in a moment, I want you to do them on your own, and in a moment, I'll come back and we'll check them. All right, for number 19, m can't be 5 from that first part, because 5 minus 5 would give you 0. And m can't be, that says negative 1, because negative 1 plus 1 would give you 0. Now, for number 20, right here, x can't be, this one sometimes is hard. 3x equals 0. Just set that equal to 0, so x can't be 0 on that one. Now, this one is going to be kind of funny. So, if you struggle with that, let's see. X is actually going to be the square root of 4 over 3. Actually, plus or minus square root of 4 over 3. So I'll show you kind of the why behind that. I'm generally not going to ask you a ton of questions like that this year. That would be like a level 4 question, but here's the how come of it. If I go 3x squared minus 4 equals 0. Draw my line down. Add 4 to both sides. If that's the case, I drop down 3x squared equals 4. All right. Now, what do I undo next? Divide by 3, divide by 3. So x squared equals 4 over 3. How do I undo x squared? To undo x squared, I take the square root. But we learned a while back that square roots always have a positive and a negative answer. So x equals plus or minus the square root of 4 over 3. Now, is that a wonky answer? It is. But welcome to math. Sometimes there are wonky answers. All right? Now, try 22 on your own and see what you come up with for that one. There are 2 answers, even though it might only look like there's 1. All right, from right here, y can't be positive 2. And from right here, y can't be positive 1. Let's go through and see if we can find, let's look at number 23. 23 isn't even solved yet. So, I want you to try to start solving that one on your own, and then I'm going to do the work and come back, and the work is just going to be there, and I want to see if you can figure it out. So try it on your own, number 23. All right, the top breaks down into 4 times the quantity of x minus 5. The bottom breaks down into 3x plus 1 and x minus 5. How come? Because 3x times 5 gives me 15x. 1x times 1 gives me 1x, and I need to come up with negative 14. So I get the negative with the 5, positive with the 1. All right, now there's going to be 2 excluded values here. So how do I find them? Well, I look at the bottom. Right here is one of them. Right here is the other. This one right here is going to be pretty nice. I will tell you right now the answer is positive 5. And my guess is that you can probably see that. So x cannot be positive 5. But this one, the value is x cannot be negative 1/3. Well, how do I get that? Because if I do 3x plus 1 equals 0, because I can't have it equal to 0, how do I undo that? Don't forget the 3. So I have to minus 1 first. Drop down, so I've got 3x equals negative 1. Divide by 3, divide by 3. So x cannot be negative 1/3. So whenever you have a number in front, when a is not equal to 1, you're going to have a fraction in there most likely. All right, so hopefully this helps. Excluded value is super, super, super important, especially as you get to Algebra 2 and Pre-Calculus, because we look at the graphs and you need to find places where the graph doesn't work.